Adelante, ingeniero Betancourt.
Muy buenos días con todas y todos. Un saludo cordial y efusivo desde la mitad del mundo para toda la audiencia que se junta esta mañana en nuestra región de Latinoamérica y el Caribe. Queremos agradecer profundamente a todo el equipo del Organismo Internacional Regional de Sanidad Agropecuaria, OIRSA, al equipo acá en Ecuador de CECELAC por la organización de esta capacitación. Hoy es nuestro segundo y último día sobre la evaluación cuantitativa de riesgos químicos para la elaboración de posición país en la comisión y en los comités del Codex Alimentarius. Deseamos resaltar la importancia y la acogida y agradecer también a todos los participantes que desde los distintos espacios, los distintos países de nuestra nutrida y variada región de Latinoamérica y el Caribe se han juntado en el primer día. Comentarles que tuvimos más de 200 participantes en la primera ocasión y vemos que se están conectando cada vez más oyentes. Agradecer al equipo de interpretación también que está apoyando para fortalecer la inclusividad con la región angloparlante y la región hispana. Caribe, CECELAC, ha mostrado un crecimiento, una maduración, una madurez muy fuerte en los últimos años en la participación en los diferentes espacios del Codex, en esas negociaciones técnicas en cada uno de los grupos de trabajo, en los comités y luego la comisión, antes de ello el ejecutivo, etcétera. Sin embargo, hay un tema en el que estamos haciendo mucho hincapié y deseamos resaltar ese esfuerzo de los países que estamos haciendo para generar data, que es importante esa capacidad analítica, la inversión, obviamente, en infraestructura, en equipos, metodologías, personal técnico, y luego después de ello, ¿qué hacemos ya con esos datos? Romper ese mito de mostrar los problemas. Y lo hablamos con, digamos, conocimiento de causa acá en la región andina y en Ecuador, sobre todo cuando teníamos, recuerdan ustedes, el tema del cadmio en las almendras de cacao y teníamos ya esos resultados luego de grandes esfuerzos de cómo o si mostrar o qué parte mostrar o no. Es importante mostrar la data, primero generarla, luego mostrarla y luego publicarla también.
Generate and publish in Simubima food webpage is something that we also have learned how to upload that data so they are available and then we can find a solution, and that's important. And I also like to stress that it's important that the OIRSA facilitates the access to the platform for all the countries, and hopefully those tools would be helpful to evaluate the risk evaluation and for the preparation for the Codex rules. And now I would like to introduce you to Mr. Raúl Peralta. Go ahead, please. Thank you very much. Thank you very much for your words. Thank you very much for the CCLAC for giving us this opportunity to share with you, well, these guidelines, how to access to the tools before, and the MSF committee that is also related with. Just give me a second so I can share my presentation with you. Thank you. Well, let me tell you what are the goals of this workshop. It was learn about the steps in a quantitative chemical risk assessment, adopt maximum limits based on quantitative risk, support harmonized based regional positions in relevant committee and WTO committee sessions, and also protect the health of consumers and facilitate trade. So briefly, the contents are, first of all, just an overview on the WTO SPS agreement and risk assessment. Based on this agreement, number 2, risk analysis in food and the Codex Alimentarius. Number 3, chemical risk assessment, where we're going to talk about the hazard identification, hazard characterization, where we're going to talk about toxicological descriptors, IDA, IDT, DRI, and along the session, we're going to talk in detail about these factors. Also, dietary exposure assessment, acute and chronic, and risk characterization, probabilistic and deterministic. This is a session, a 2-hour session, and you know this will take us a week, but we're going to try to address the main points on risk assessment of chemical risk. As you may know, next June the 7th, we're going to have a World Food Safety Day, and this is an initiative from the Codex, and also a proposal for the Latin American and the Caribbean, the CCLAC Food Committee, with the support of the whole region, and that was later approved by the UN Nations Assembly, and that's why every June 7th we celebrate Food Safety Day. And today we are going to focus on prepare for the unexpected, in which we're going to discuss the responsibilities of all the participants, the members, producers, and consumers. Okay, so in relation with the WTO SPS agreement, this is an international treaty of the World Trade Organization, and the agreement says that all members have the right to adopt any sanitary and phytosanitary measure that are necessary to protect human, animal, and plant health life. So this agreement addresses into the main interest of the members, and members shall ensure that any SPS measure is applied only to the extent that is necessary to protect human, animal, or plant life, or vegetable life. And this is the only agreement that covers this part and is based on scientific principles. Also, SPS measures are not discriminatory and do not constitute a disguised restriction on trade. So this is basically the SMF agreement. So the area that corresponds to us is merchandise trade related to the world trade of merchandise, and this information is from the WTO, that food represents 8.06% of all the total merchandise that is trade around the world. And even though this is a small percentage, the agreement of the WTO was very hard to finally have it approved. And at the beginning, we had an approach on risk, and then we introduced a protection approach. Article 5 of the ESPS agreement says that is got to do with risk assessment. So Article 5 establishes that all members shall ensure that their SPS measures are based on a risk assessment, taking into account risk assessment techniques that are developed by relevant international organizations. Now, in the case of food, The members will base their SPS measurements on standards, guidelines, or recommendations in international agreements. And as for food safety, the standards, guidelines, and recommendations established by the Codex Alimentarius Commission on Food Additives, residues on veterinary drugs and pesticides, contaminants, methods of analysis and sampling, and cuts on guidelines and hygiene practices. And now this is just for your general information, so you can see how important it is, food safety in this agreement. Of all the notifications that have been sent to the WTO through this SPS agreement from 1995 to 2024, 47.97% is related to food safety. There, 6.3% food safety, 13.6 had to do with food safety too, and 6.3% also related to food safety. So more than 50% of all the notifications that have been sent to the WTO through the SPS agreement have to do with food safety. And from all the keywords that have been included in the notifications, 20,510 words have to do with health. And then if we add all the importance on chemical risk had to do with the most number of keywords. So most of the discussions that are bring up to the committee are related to food safety. So what I mean is, it's not that the other areas are not important, but this show us how important it is, food safety and the trade of food worldwide. This information, we took it from UE page. These are the notifications that are related to alert and the UA border from all the food that is important from Latin America during the 2020-2024 term. There are 834 notifications, and from them, 418 notifications are related to chemical danger. And from those chemical danger, most of them, 188 are mycotoxins, 153 plaguicides, 41 others, and 36 are heavy metals. So these are related to mycotoxins, are cadmium, plaguicides, and others. So these are the main risks that the UE have been detected that got to do from most of the food that are imported from Latin America. I try to consult with from the FDA website, but it's not so friendly. So now, risk assessments versus risk analysis. Like I say at the beginning, the SPS agreement had to do with risk evaluation. So the risk evaluation is the assessment of the probability of possible harmful effects on human health from the presence of additives, contaminants, toxins, or pathogenic organisms in food products, beverage, or feed. That is the SPS agreement. Now, the Codex Alimentarius talks about risk analysis, and risk analysis is used to prepare an estimate of risk to human health and safety, identify and apply appropriate measures to control risks, and communicate with interested parties to notify them about the risk and measure applied. So the Codex talks about risk analysis. And in 2003, the Codex Committee adopted the working principles for risk analysis and its application within the framework of Codex Alimentarius that was developed by the Codex Committee on General Principles. And food safety risk analysis is used by the Codex Alimentarius Commission and its subsidiary bodies to develop standards and related text. So all the guidelines that Codex developed are based on the risk analysis. From all the Codex committees, that means we have general committee and product committees. From the general committees, 5 of them are related with food safety. Contaminant committee, the additive committee, the committee on hygiene of food hygiene, Codex committee on food import and export inspection and certification system. 5 of these committees, 4 of them have to do with contaminants on food. So Codex risk analysis, like I said before, it has 3 parts: risk communication, risk evaluation, and risk management. Decisions related to policies and values to protect consumers and facilitate food trade. That these aren't any obstacles for food trade. So scientific basis of Codex. Risk analysis is the cornerstone for the establishment of control measures in foods, and it is an integral part of the Codex decision-making process. Codex principles and guidelines on risk analysis are used by Codex subsidiary bodies. So what are those auxiliary or advisory bodies of the Codex? So Codex has the scientific advisory bodies. Like I said before, we're going to refer to as all of those that have to do with residues and contaminants. The joint FAO-WHO expert committees on food additives establishes the Codex, the IT, ADI, MLR, and good meeting on pesticides and good practices. This committee responds or provides some advisory to support Codex Additives Committees, Codex Committee on Contaminants, and Codex Committee on Veterinary Drug Residues. So these 3 committees have to do with the GECFA. The other entity is the joint FAO-WHO meeting on pesticide residues that establishes the maximum limit intake on the good practices. And this committee works for the Codex Committee on plaguicides. What is the procedure to establish maximum limits of contaminants, additives, pesticides, and veterinary drugs? So we have 3 different stages. The first one is to identify if there is some risk for health and what are those kind of foods that we should establish the maximum limits of intake. So in this stage, we evaluate the dietary probability that the contaminant exceeds the safe tolerable dietary exposure level. And also in this first stage, we determine which food should be determined the maximum limits using 4 criteria. From this stage, we start asking for information to the different countries. The second stage is the set of maximum limits. In this stage, we prepare the project based on stage 1, and the total exposure assessments based on maximum levels that are found on stage 1. The stage 3 is the assessment of consumer protection. Here we are going to evaluate the total exposure, and we estimate the total concentration of contaminants on food. In the 4th stage, we establish the maximum limits, and we evaluate the total risk of the total affection, considering that does not exceed the maximum level. And we also determine if there are saved and what are the maximum levels in food. This is just a brief summary of the different stages to establish maximum limits. So there are some differences among the risk analysis and hazardous evaluation. And so we also talk about the different chemicals and biological risk on food. Also includes some other factors. Risk assessment. We are going to focus on this part. We're not going to talk about risk management or risk communication. We'll only talk about risk assessment. So risk assessment is the most important component of risk analysis, and it provides the scientific basis for risk management decisions. So that means risk assessment is the main information for scientific that is important to make decisions. All relevant scientific information available is taken into account, and uncertainties in the knowledge base are identified. It includes 4 steps: hazard identification, hazard characterization, including determination of dose response relationship, exposure determination, and risk characterization. Everything that is related to chemical risk assessment in food. The main job of JEFCA and JMPR is to evaluate the risk of chemical origin in food. This is their main job of these committees. And the countries at national level and the Codex Alimentarius Commission at the international level take measures to ensure food safety based on the recommendations of these committees. That means that the recommendations of these committees are adopted by the countries that are members and the international other countries. So these committees based the recommendation on scientific principles, and the Codex Commission and their committees, in this case, the additive and contaminants committees, pesticides and veterinary drugs contaminants, adopted their final decisions on the maximum limits on pesticide residues, veterinary drugs, contaminants, and additives permissible in food, and other related measures. Here we have a summary of chemical risk assessment that follows the 4 different stages, which is hazard assessment, which corresponds to the stage on the definition of hazard, the part of exposure assessment, and hazard identification and hazard characterization. Hazard identification. In this stage, JEFCA and GPMR require the information from the countries about in vitro studies and live studies. It's not that these committees conduct these two different studies, but they take the information or the data from these studies so they may identify hazards. In this hazard identification stage, we identify the adverse health effects and the interaction of chemical substance with a biological target. This stage includes data on toxicogenetics, absorption, distribution, and metabolism and elimination. We're not going to work on this hazard identification because the hazards are already identified. If we're going to conduct risk assessment, we're not going to identify aflatoxins because these are already being identified. It's not that we cannot conduct other studies, but we already have that information. So that information, that data, we're going to find in any biography or on a meta-analysis. The other stage is hazard characterization, and this have to do, the second stage has to do with a quantitative description of the potential that the intrinsic property of a substance may cause adverse effects. In this stage, we establish the dose-effect relationship, which describes the association between dose and the magnitude of an average biological change in an individual or population. In this stage, the purpose of hazard characterization is to identify a numerical value that can be used as a reference value when considering exposure in the risk characterization. So if during the hazard characterization, we cannot evaluate in a quantitative manner the characterization of hazard. In this stage, we established ADI for avoidable substance, for instance, additives and pesticides residues or veterinary medication, or we can also establish the limit for unavoidable substances such as mycotoxins and heavy metals. In this stage, determination of the dose response and the relationship, we're going to talk a little bit about this. Here, the dose response is established on the basis of a complete review of the data available through observations made in experimental animals and observations made in humans. Here we describe the possibility or probability of a specific response from exposure to a chemical in a given population as a functional of those. Also, the units of daily intake or maximum tolerable intake mg per kilogram body mass, body day, or oral administration. To determine the dose-response relationship, we use two approaches. First of all, an analysis that provides a quantitative or qualitative estimate of risk, and two, analysis that establish guide values for exposure limits based on health criteria, such as acceptable daily intake, ADI, or tolerable daily intake. Like I say, daily intake, the maximum daily intake are used for inevitable contaminants like heavy metals and mycotoxins, etc. The tolerable daily intake, or TDI, are used for food additives, pesticide residues, and drug residues, drug veterinary residues. So how do we manage the dose response modeling? The data that we obtain from experimental animals, we extract this data from animals to humans. Also, we extrapolate the differences between humans regarding to the response. So there is an extrapolation between species and between species from animals to humans. And the first or the main method used by GACFAA and GMPR is to define the level of no observed adverse effect level or the lowest observed adverse effect level. So this is the first method that are used by the JEFCA and GPMR to define that extrapolation to humans. Also, we use the lower limit of the unilateral confidence interval of the reference dose, known as BMDL. This method consists on using the lower limit of the unilateral confidence interval of the reference dose as a benchmark dose to estimate the limit of exposure as a starting point to calculate a guide value for the exposure limit based on health criteria. In general, these methods provide us a certain limit, but the BMDL is used to define the dose related with an negligible increase in response, for instance, 1 in 1 million from the reference. And this method has become the preferred dose response assessment method for the US EPA and the EU EFSA. That's why many times we can see or we notice the EPSA proposes maximum levels that are a lot lower than the other committees. So these depends on what are the techniques that have been used to determine the dose response modeling. So how do we model the dose response? The daily intake, the tolerable daily intake, the BMDL, or the reference acute dose, those are numerical and are expressed in milligram per kilogram per body weight per person per day, and a single significant figure is used. In the case of GMPR and GCFAI, they calculate an acute reference dose that are present in food and drinking water, or both cases, that can be ingested in a period of 24 hours or less without any risk to consumers' health. So these two committees, GMPR and GECFA, besides that, they calculate a tolerant admissible daily intake, they also calculate acute reference dose. So how to derive the ATE from NOEL or LAOEL? So this is an example that are estimated from the JEFPA and GMPR from a NOEL or LOEL. So we have effects for imidacloprid to diminish the body weight. Let me see. Okay. So this one, we said that the studies conducted in animals, they determined that the NOEL of 5.25 milligrams per kilogram per day, there had no effect on health. This 5.25 milligrams was established for an IDA. So we took a evaluation factor in interspecies of 10, a factor evaluation, a second factor evaluation of interspecies text, evaluation factor or duration of 1, uncertainty factor 1. So we multiply among them and we divided between 5.25, and so we have the result of 0.05 milligram per kilogram per day. So this is the admissible daily intake, and this is the number that we use to establish the maximum limit of a residue. So on your right, we have another result of IDA and LOEL, which is a minimal level that we observe some effects on health. So we here determine LOEL on animals on 40 milligrams per kilogram per day. So we took the same evaluation factor, interspecies 10, another of 10, a duration factor of 2, uncertainty factor of 5, because uncertainty in on a LOEL it's higher. We multiply times per 10, per 2, per 5, and it's equal to 1,000, and then we calculate 0.0 milligram kilogram per day. So that means when the JEFCA and GMPL establish a response dose is because the protection of health, we can say, with the different degrees of uncertainty, that means health is well protected. Now, unavoidable food contaminants. That means, so these are about unavoidable food contaminants. So these are used for the term tolerable for guideline values, which indicates that the ingestion of contaminants are associated with food consumption is acceptable. The principles for calculating tolerable intake levels are the same as for ADI. So this is the same principle, which is based on the as low as reasonable achievable or ALARA principle. The guide values can be for unavoidable food contaminants are maximum tolerable daily intake for contaminants that do not accumulate, provisional tolerable weekly intake for contaminants that accumulate, provisional tolerable, that means that we are going to hear about all this terminology on contaminants that are unavoidable for instance, heavy metals and lipotoxins. Now, what happens with carcinogen contaminants? So for this type of genotoxic and carcinogenic substances, there may be some degree of risk at any level of exposure. So for those substances that are carcinogenist, the GCFEA does not establish a health-based reference values for substances known to be genotoxic, but they are unavailable. In these cases, we obtain the margin of exposure for carcinogen toxins. We establish MEOE of 1 in a million cancer risk is estimated from linear extrapolation of PMDL10, and it is expressed in milligrams per body weight per day. Here I have, I show you, I have two different graphics. For carcinogen risk, we have a threshold in which we have no effect at some point. So carcinogen substances can have an effect at any level of exposure. So that's the probability on the production of or the cause of tumors. So because we don't have zero risk, we have a exposure margin that we establish as a base. We're going to see that on microtoxins on heavy metals. So this is what we have to do with the risk characterization. If we haven't had the risk determination, we cannot reach the third stage, which is exposure determination. I don't know if you have any questions about it about now. Okay, so in relation with exposure, we can determine acute exposure or chronic exposure. The dietary exposure determinations cover the general population and also vulnerable groups. JEFA and NPR applied the same method for contaminants, food additives, pesticide residues, and veterinary drugs. This is the general dietary exposure, which is concentration of chemical substance in food times food consumption divided on body weight in kilograms. So this is the general formula. So what are the information sources of information that we need? Sources of information that we need on concentrations of chemical substances in food. If we want to really conduct an exposure assessment, so where or how can we find this data on concentration? The first one are the proposed maximum levels on or maximum residual limits. So where can we find this data on maximum residual limits? We can find them because when we propose a maximum limit, we can find that information. So we can consult that at the Codex page. We also have levels proposed by the manufacturer in case of food additives. We have monitoring and surveillance data from our countries, thorough diet studies, the GEMS food database, studies on the elimination of residues or veterinary drugs, and the studies of the highest and average levels of residues in supervised pesticide trials, as well as scientific bibliography. Those are the source of information that we have to conduct a good assessment on food. We have plenty of information available there. Here, I would like to show you the Codex Alimentarius webpage, where we have the limits of plaguicides and medical veterinarian residues. Here you have a chart. So this is the database of the total GEMS food database. So there are 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. There are 13 different clusters of GEMS food on food consumption by diet group. In the case of our countries, we have in the K group includes Antigua, Brazil, Bermudas, Bahamas, Barbados, Belize, etc. The group H includes Venezuela, El Salvador, Guatemala, Fiji, etc. So this information is also available. We can also share it with you as an input. So what is the problem? So these are average quantities. I was looking, for instance, in the K group in the Dominican Republic. So the rice consumption is 119.5 grams per person per day. So this is close to the average amount. But for instance, Nicaragua and Panama, there are more important consumers of rice that include a higher level of consumption, but this information is available for you. So we also have to document the dietary exposure. So when it comes to conduct a dietary assessment, we have to document which dietary model we have selected, if it's GEMS food database, if it's a local food database, etc., etc. So food definitions, sources of data on food consumption, the concentrations of chemicals in food, and model assumptions that can be documented for transparency in documentations. Supervised trials only for pesticide residues. For us, this is a key part, because in our countries, when we record a plagicide or register a plagicide, at least in my country, the experience in my country, what we do is we conduct a performance test of the pesticide. We do not include an examination on the components. So we just include a trial or a test of the registered pesticides. And these tests are designed to determine the maximum concentrations of residues that may be present in the harvested product. So the residue in these tests do not include the residues that may probably be included in food the way we buy them and we eat them every day. So we include the information residue concentrations likely to be found in foods that are actually consumed. So this had to do with the supervised test. So residue depletion studies, there are only for veterinary drug residues only. We request residue elimination study data, and these results must be submitted to the regulators. So these studies have to be sent to regulators to support drug registration. These studies, they're usually conducted by the producer or other entities that are the manufacturer, using commercial formulation and recommendation on recommended dose. Also, JEFTA use this information to define a maximum level intake. In the case of veterinary residues, are used to represent the 95% limit of concentration of residues as the chosen time point of the residue depletion curve. So what do? What we need to do is to verify the maximum limits of consumption in our countries. Monitoring and surveillance data. There are two different ones. There is a selective or random sampling. These data are suitable for post-regulation, acute and chronic dietary exposure assessment. So after that we have adopted maximum limit, we may use the samples or random samples to conduct the evaluation after the regulation. There are also samples for law enforcement purposes in response to specific problems. These information are not appropriate to estimate dietary exposure assessments. Principles of dietary exposure. Risk assessments must be based on realistic exposure scenarios, considering different situations defined by the risk assessment policy. They should include the consideration of susceptible and high-risk population groups, the children, pregnant women, etc. There must cover the general population, specific population subgroups, infants, children, pregnant women, older adults, and people at the upper end of the exposure distribution. So these are the principles that we may have had on hand when we conduct a dietary exposure assessment.
Tenemos dos tipos, podemos hacer dos tipos de.
So we may conduct two different types of dietary exposure, the deterministic and the probabilistic exposure to chemicals in food. The deterministic or punctual non-parametric is simply a single value that describes some parameter of consumer exposure. For example, the average exposure of a population. The probabilistic parametric characterizes the full distribution of consumer exposure to chemicals in foods. The methods for probabilistic models are simple empirical estimation of distribution. If we don't have enough data, we may conduct a probabilistic model or an empirical estimation, probabilistic models from data sets, stratified sampling, just like the Monte Carlo simulation that are randomized sampling. Here I'm showing you a deterministic model. We have the average and the probabilistic that we have different scenarios. In case of probabilistic or stochastic estimate, the structure of a probabilistic or scholastic model is similar to that of deterministic models. It uses the same formula. It is based on the same basic equations to estimate dietary exposure, that the dietary exposure is equal to the concentration of the contaminant divided by the body weight. It's the same equation. The difference is that the variables are represented by the distribution instead of a single value. We have a mode, mean, and standard deviation. We can have a 19, 60, 70 percentile. We have a higher and lower level. So what are the alternatives to using of the mean? We can use the median concentration for chemicals where there are few data points. We may trim the distribution to eliminate outliers when it is considered that they do not represent the levels at which people are likely to be exposed. Then calculating the value of the arithmetic mean. Use an alternative method to define the measure of central tendency. For example, the mode geometric mean, which reduces the impact to your right. You have an example, because sometimes we can have a normal distribution that shows us a very pretty model. So this is a real example of about 400 different aflatoxins data. And here you can see the shapes of the distribution. The medium using all the data is 65.6 micrograms per kilogram. The medium was 0.7 micrograms per kilogram. The mode was 0.0 micrograms per kilogram per hour. The geometrical media is 8.88 and the medium is 60.98. That means in our cases, if you ask me which value I would like to I choose for the assessment, I rather use the medium arithmetic number, and I would prefer to use the highest value just to make sure that I'm protecting consumers, even though this may affect the producers. Because if I use the media, I may not take into considerations the people that are included in the highest values that are exposed to aflatoxins. if the WTO do not have enough data to estimate the values, so WHO recommends that if we only have the 90 percentile equals to 2 means. To your right, I am showing you this estimate. 95 percentile means 2.5 means. 90.7 percentile is equals to 3 means. You can see here that two means represent 90% of the total data, because this distribution equals to 5%, the 95%, we will have a small remain of 5%, and 97.5 percentile that will show us two different intervals. So those are different options when we don't have enough information. We also have the empirical estimation of the normal distribution. The empirical rule, also called the 68, 95, 99.7 rule, is only a statistical rule that describes the distribution of data in a normal distribution. Now, be very careful with this, because it only applies to normal distributions. You cannot apply it to a different kind of distribution. This is only for data that is normally distributed. So in the case of the aflatoxin, we cannot use this empirical rule, and if this only shows approximate values, and the rule involves that the media more plus standard deviation is equivalent to 68% of the total data. That's two medium, standard medium is equivalent to 95.45, and the other one would be equivalent to 99.72% of data. So what happens when we have results below LOD or LOQ? LOD is the max determination level, and LOQ is the quantification level. So LOD is where the lab sends us a level, but we cannot quantify that. And so the LOQ is the maximum level where we can measure. Appropriate handling of quantified results is essential in dietary exposure. So we have three different options that we recommend. So if you are evaluating the exposure, you may determine the level you're going to assess. The first of all is to assign a value of 0, the lower level. The second option for me is the most appropriate, is to take the LOD or the media or the medium limit. For instance, if we have a limit of 10 micrograms and the lab sends us a result of the maximum level of quantification, we may assign a maximum level of 5. We may also assign the value of LOD or higher limit. And in this case, we would be a little bit more conservative when it comes to protect the consumer's health. Types of dietary exposure for chemical substances. So before it's an MLR or maximum exposure is used, or before the regulation, we may conduct an assessment of food limit. So we can take this as a scientific basis, so we can discuss this with the different committees. We may conduct an evaluation after this limit has been approved and potentially been in the food supply for years. That means post-regulation or the current MRLs. We can also conduct an assessment for substances that are present naturally in food or as a result of contamination. For example, the aflatoxins. the acute dietary exposure estimation. GMPR and JEPCA estimate the acute dietary exposure using international short-term dietary exposure estimate that is called EST. So these two committees have a database that includes all the GEMS database that is available to calculate acute exposure. So acute exposure corresponds to the expected intake of one or more foods for a short period of time. For this calculation, we include the size of the largest consumption portion of food and the highest concentration of residues or chemical contaminants in food. So briefly, to summarize, this is the sum of the higher concentration of the contaminant per milligram per kilogram times the largest portion of food consumed per day divided by body weight. So with this simple equation, we may conduct an evaluation of acute exposure. So before the regulation and after the regulation. Estimation of chronic dietary exposure. GMPR and JEPCA estimate chronic dietary using the International Dietary Exposure Estimate. There is a GEMS food database using the different food diet groups. The GEMS food group diets express per capita consumption on population average, but it does not provide information on subpopulations or variability. Individual food consumption, individual dietary records are the most appropriate for the assessment of chronic dietary exposure. And for the IED, we use this equation. The total of contaminant concentration times food consumption per kilogram per day divided by body weight. We're going to see some examples. We are going to use also a global estimation of chronic food exposure. The FAO WHO expert meeting in 2011 proposed a global chronic dietary exposure estimation methodology in 2019. This approach is based on summary statistics of national food consumption data from CIFOCO's database. And in this meeting, the proposal was to use the 97.5 percentile food consumption values used for high-level consumption, and also 90 and 95 percentile as they represent high chronic regular consumption. I'm going to show you summary statistics database. I'm going to try to access to this database. I think it's right here. But okay, so you can try to access to this link, and you can see that this database. I download this database, and I have it right here. Let me see if I can open it to show it to you.
Es importante. Correctamente, sí. Mire, esta base de datos usted se puede bajar
So you can access this database and you can open it in Excel. This is the most broad and complete database on food consumption you can find. So what is the inconvenience here for us in our countries in Latin America is that in this database, You can see this in Excel. So this database includes more than 40 million different data. If you filter and search for countries, as for our region, we only have, let's see, Brazil, Guatemala, Mexico, and Peru. So this are the Latin American countries that have information on WTO, and we may use that to conduct risk assessment. So what is the advantage? So I have a table here, and if I search here and I like to compare the information, I can use a filter per country. In the case of Guatemala, which is a country from our region, well, here we have information of cereal consumption, eggs from Brazil, Guatemala, Mexico, and Peru. We can see the different information, but in my filter, I can only search for the specific information that I want to see from each country, because the database allows me to filter the information. Let's say if I like to look for information for the 95 percentile, if 90 percentile 95, 95 percentile 90 here, for women, men, children, per age group. So I have all this information available in this database, but we only have 4 countries that from all over region that share the information in this database. We're going to continue with the presentation then. Well, here we have a sample on the web page of the World Health Organization and how we can access to this database, and we can download it in CZUB and then download it on Excel, and then we can search for the information with the filters. And like I said, there are 4 countries from a region that have information available on complete diets. In the case of Guatemala, the information is from 2012, but remember that food habits do not change that fast. We have the theoretical maximum daily intake, the MTDI. So how can we estimate the maximum daily intake? To estimate the maximum daily intake, DMRs are very helpful to conduct an estimate of the maximum daily intake. So we do not have to have a monitoring information. From the IDMT is estimated by multiplying the MR, the maximum level of intake by the estimate average daily consumption of each product in our country. And then we divide this result by the body weight. After that, we compare with the admissible daily intake or the reference daily intake. This is the equation to estimate the maximum daily intake, and we obtain this by adding the food consumption by body weight. So we can do that if we use the database available. So if we don't have any information about our countries, we can use this information available from other countries just as a reference. We can also estimate the international maximum daily intake, and this includes correction factors for its application at the international level. If we have information available from our countries, we can estimate or to refine the intake estimated based on the available information. But in this one, we use correction factors as can be the residue concentration in supervised trials, the partly edible waste, practical effects of preparation and cooking, and known uses of pesticides. That's why the CMRI residue concentration in test, we use it as an international estimate intake. So JEFCA uses these correction methods. And what we can do is to estimate the national theoretical maximum daily intake, because we can apply those to our country, and we can use to confirm the maximum daily theoretical intake by JEFCA and GPMR, because they estimate a daily intake based on different groups per country, but we can adjust that to our countries, because this also includes different factors that are also considering at international level. So the maximum theoretical intake is estimated by multiplying the maximum proposed limit or the established by the average daily consumption of each product at the national level. This also may be useful in assessing the acceptability of a maximum MRL, and it is divided by the body weight. And then we compare that information with the IDA or the BMDL, and it's the same equation to estimate the daily theoretical intake at national level. This is an example of the estimation of national theoretical maximum daily intake of toxic pollutants. I have an example for you. So if Macondo authorities wish to evaluate for acceptance, so maximum aflatoxin levels in foods, maximum limit of residues for silpaterol, and we know how broad this discussion was conducted in the committee. Maximum level for glyphosate. So the evaluation wants to know if the population is protected enough. What are the Macondo information available for Macondo? What are the Codex NM aflatoxins? Where can we find that? In the Codex database. Maximum limits for Codex silpaterol. We can also find it in the Codex database. Also, the maximum levels for glyphosate at the Codex database. And let's say that Macondo doesn't have any information available on consumption data, but Macondo learned that the WTO has a database that is called FAUSTAT that includes the consumption data average of our countries. And with that information, the authorities of Macondo request their technicians or their experts to conduct an evaluation to check if it's possible to accept these maximum levels. So where can we find the consumption information? So WTO has this database available. Besides the GEMS database, we also have available this WTO that, of course, this is just an average information, but it is available. So the part that has to do with food information, we can also search by country, and we can select all the food or different types of food that we want to find. And there is also an option that says elements. We can choose food per group of person per year, per kilogram per person per year. And we can also filter all the different years that are from 2010, 2021, and we can also estimate an average. This is for consumption. So the silpaterol levels. So we have the Codex database here. We have the maximum residue limits for silpaterol chlorhydrate. So here we have liver 3.3 micrograms per kilogram. So liver 3.5 micrograms per kilogram. The species, the referred to muscle 0.5 micrograms per kilogram. So here, when we open this database, we can also find the maximum dietary daily intake. So starting from 0.0 micrograms per kilograms per day. So I have the dose and the response, and we also have the maximum level of intake to assess the exposition of the. So the database provides all this information. So referring to cattle, the daily admissible intake it was taken from these percentages, including the toxicological description or the uncertainty values that we can include to estimate the daily intake for humans. In the case for pesticides, it's the same information. We enter the Codex database and we can check the maximum intake levels for glyphosate. And they are classified by food groups, the year of adoption. And also in this database, in the Codex database, we include the daily admissible intake. That it means that for glyphosate is from 0 to 1 milligram per kilogram per body weight per day. So we also have this information available. And for the case for aflatoxins, we have the Codex regulations on contaminants that provides a maximum level established for aflatoxin in different group foods. But except that we are missing the specific information in this case, we have to find it in another section. So with this information, I know that you can really see that, but I'd be happy to share it with you. So with all the information that is provided, you can elaborate, you can open up an Excel sheet and download the information from the WTO database. We can have the annual consumption per person per kilogram per day, and then we divide it by 365, and then we can have the daily consumption. In this column, we added the maximum limits for aflatoxin. We multiply by the daily intake. So the maximum established limit, we multiply by the consumption, and then at the end, we add up. I'm sorry. Okay. So we add up the total.
Acá hicimos la sumatoria y ya ahí calculamos
And then
la ingesta-
we estimated
la ingesta
the
máxima tolerable
maximum
para cada uno de esos alimentos.
intake for
Ya tenemos
each
la
of
expresión.
those
Y acá le muestro
foods. In here, I
de manera
can
más
show
sencilla
you
un ejemplo
in
de
a
cómo
very
la exposición, la ingesta
simple
diaria máxima
example.
tolerable
So the
del
maximum limit
LMR es igual a la
intake
sumatoria del
is
LMR
equal to the LMR, or the maximum level, in milligrams on kilogram or kilogram per day, multiplied by kilogram per day, divided by body weight. And the average is 60 kilograms. We know that the media is very low. So the daily maximum intake, which is a theoretical national information for glyphosate, is 0.10 milligram per kilogram per body weight per person per day. How do we obtain that? We multiply the maximum limiter by established by Codex, and we divide it by the food and the body weight, which is 60 kilograms. The aflatoxin estimate was 0.071 micromilligrams per kilograms per body weight per person per day, multiplied by the national limit adopted by Codex for the consumption of food and divided between the body weight. In the case for salpaterol was 0.0003 microgram per kilogram per body weight per person per day, multiplied by the Codex limit by the food consumption and the body weight. The WTO and the FAO estimate that to conduct an evaluation for exposure, maximum exposure, where we use maximum levels or maximum estimates, we estimate that 50% of food that has been established a limit, there be closer to the maximum level established, and the other 50% may be around the maximum media that has been established. And also they recommend that there are some foods that may contain this contaminant, but there haven't been established any maximum levels. But they say you can estimate 28%. So that means that you can use this information to play around to see if this gives you some kind of a idea. So we haven't included the risk characterization. This is only about exposure. Now, about risk characterization, which is the third phase or the third stage. Dietary exposure is compared to the health-based guideline value. So what are these values? Are the health maximum intake, monthly intake, or for carcinogenic or genotoxic substances, are the guidelines for cancer potency factor. So these may be related to acute or chronic toxicological endpoint. For carcinogenic or genotoxic substances, JEFCA and GMPR set a guideline for cancer potency factor for exposure limits based on health criteria. The equation for risk assessment is chronic exposure in milligram per kilogram divided by acceptable daily intake. So the chronic or acute exposure is divided by between the maximum daily intake, and we divide it by as a percentage of these values. So this is an example of the assessment that we did before. This information, for instance, this is the silpaterol exposure and risk characterization. I wrote here Mediasta, but it's Macondo. For 2024, the silpaterol exposure was 0.03 micrograms per kilogram per body weight per person per day, but the maximum daily intake is 0.4 microgram per kilogram per body weight per person per day. When I divide 0.0003 micrograms by 0.04, the percentage is that the risk is 0.75% of daily admissible intake. That means, like you can see in this example, the blue chart, it's the maximum daily percentage. The 0.3 means the maximum exposure, I'm sorry. So the authorities may accept that there is no risk for consumers from 0.3, because that would be the maximum level of exposure for the population. In the case of aflatoxin, we did the same. So the maximum theoretical intake at national level, which is 0.071 micrograms per kilogram per body weight per person per day, we divided by JEFCA for, let's say, for liver cancer, which is 0.3 micrograms per day. When we divide that, the risk is equal to 0.23%. So at that level, the risk is still tolerable for aflatoxin. So these maximum levels are acceptable. And I would like to stress that the information that we use are from real information, from real data from a country and our region. In the case for glyphosate, is the same. The risk exposure is 10% of the daily admissible intake, according with the GMPR for glyphosate. So the levels, the maximum levels for glyphosate are not a risk for consumers if they are managed as according to good practices. So what are those factors to improve estimates of toxic residues, concentrations, and predict long-term ingestion through food? At national and international level, first, we have residue concentration in supervised trials. So we have this information, and we may just perfectionate this information. So we need to conduct this test on a specialized lab. We also have effects on processing and cooking of waste concentrations. So those are the concentrations that are available for consumers. We have other known uses of pesticides. At national level, we have proportions of the crop or product that is treated in the country of import, monitoring and surveillance data, total diet studies on basic food, food consumption data, including subgroups. And in this case, we can also use the Monte Carlo simulation evaluation risk. So here we have another example. The first example I gave you was exposure of a deterministic type. This is an example of probabilistic exposure. This is for Mediastia. Mediastia conducted a monitoring in which it determined that the levels of aflatoxins, and this is information that that was a result of a monitoring. So corn with a media of 18 micrograms and standard deviation of 3.24, rice 12 micrograms and a media of 2.16, wheat 8 micrograms and standard deviation of 3, peanuts 20 micrograms of total aflatoxin and a standard deviation of 4. And Mediastia wanted to conduct another evaluation to determine cancer liver risk and to see if in fact the concentration is the maximum level of 0.3 micrograms per kilogram per body weight per day, according to JAFCA. Also, we have the annual consumption data, and in men is 40, women 30, and children from 8 to 15, 25. In rice is 33, 30, and 20, respectively, wheat 30, 28, and 20, and peanut 5, 3, 1. And also there is an average per kilogram. For men, the minimum is 50, maximum 74, excuse me, most probably 74 and maximum 125. Women, minimum 45, 70, 100, and children 15, 30, 45. So here we have more information. Here we can apply the Monte Carlo simulation chart. We can use distribution for different concentration of aflatoxin in corn, aflatoxin in rice, and we have more comprehensive information that the risk manager can have available, so that we have the percentile 2.5 to 95%, 5 maximum, minimum, maximum 99.5 percentile. So we have a broad information available when we want to conduct a probabilistic assessment. Here we can reach this information, and we can also conduct some simulation in Excel. But if you, we send you an exercise in Monte Carlo, but you have to have the software available. Now you can download that software in the Monte Carlo simulator for free. You can use it during 2 weeks and you can play around with this information. So you have all the information summary that we can conduct from simulation of aflatoxin for different trust intervals. The exposure we can estimate by the percentile, different percentiles, different scales for aflatoxins, the minimum, maximum, the media, the standard deviation. So here we have a lot more information, and so risk manager may have more information available, and therefore there are more benefits, so we can conduct probabilistic studies. Okay, so I've talked way too much. So to summarize, risk assessment is the scientific component of food risk analysis. The Codex is the only international organization up to date which is recognized by the WTO SPS agreement for the development of standards in the field of food safety. Even though the agreement talks about organizations, only includes the Codex food. The Codex standards are adopted based on scientific principles according to the recommendations of its scientific advisory bodies. JECFA and GPMR are the scientific advisory bodies to recommend the adoption of science-based maximum limits. Chemical risk assessment consists of 4 steps, just like the microbiologic evaluation. So includes hazard identification in vivo and in vitro studies. We are not going to conduct in vivo and in vitro studies, but our countries may have information available, and we may include this to the different platforms and share it in these groups. The second stage is the hazard characterization, establish the admissible daily intake, acute intake establishment. This is already established, but I highly recommend that you consult, study, and get familiar with this information. So these limits are established by the GMPR, and all these studies that have been conducted in other countries should provide the information of this study. Now, exposure assessments can be conducted before adopting a maximum limit consumption after adopting an MLR for a avoidable substance. And this can be very helpful to request a new evaluation of maximum daily intake. If we determine that in our evaluation that there is a risk for consumers, we can recommend a new level. And the risk characterization phase will determine the proportion of the exposure. So it's important to determine what would be the level of exposure on the toxicological descriptor. So in the third phase, which is exposure assessment, we compare the data of the assessment on exposure with the risk characterization data of the risk, so we can determine the proportion of risk or the level of risk. So how do we define risk level? If it's higher or equal to 1, the risk is intolerable. If it's less than 1, the risk is tolerable. You can find this information in some kind of websites. You can see that if it's higher than 1 is intolerable, if it's less than 1 is tolerable. If you agree with this, of course, if the exposure is equal to the toxicological descriptor of IDA, I wouldn't say it's a lower risk. I would say that is intolerable. And a chemical evaluation assessment and a chemical assessment, you include the food consumption data. If you don't have this information available from your country and you don't have surveillance data, you may conduct deterministic assessment, including the CMR information using the Codex, the FAUSTAT, or the diet database, the GEMS database. And with this, you can have a close idea or close estimate. My idea is you should try to be really conservative when you are trying to determine chemical risk, because if there is any error on the accuracy of the result, you can still have a little gap that may protect your consumers. And so we can request our authorities that when they approve some veterinarian medication, they could give you, so share the information on the medication, so we can include those estimates in our evaluations on risk level on chemicals. Also, in the case of pesticides, if we include the highest number of risk and the use of the pesticides, we can evaluate if there's no risk for our consumers. So I would finally like to invite you to share this event, which is organized by CCLAC and the WTO, ICA and OIRSA. This will take place on June 5th for World's Food Safety. And thank you very much. And if you have any questions, please let me know. Thank you very much. Yes, we do have some questions. So thank you very much for all the colleagues that are with us from Colombia, Nicaragua, Peru, Argentina, Honduras, Costa Rica, and all the rest of the countries that are here in this session with us, attending. So Joanna Anchundia has a question and she says, all this material has been shared with the CELAC link, but you can also add up your email address and we can share it. So the question is, so excuse me, so the depletion, no. Okay, so the studies of residues depletion are the same ones that are used by the GMPR to assess the good practices to adopt a maximum MR. So these studies we can conduct in our countries. What I've seen in Dominican Republic is that the manufacturer, when they request to register a new product, let's say something that includes niproline that is recommended for different plagues, they have to demonstrate that it is efficient to control pests, but there are limits when it comes to concentrations, because we want to prove that they're not going to affect the plants or the products for consumers. So they all have to have some authorized methods regarding the concentration of chemicals. So this is it for me, and thank you very much for attending this session. Thank you very much, Raúl, and all the team from OIRSA for this session. It was very interesting. I only would like to ask if there is any other question, because we have a couple of minutes more. So no, there are no more questions from the public. Thank you. Thank you very much. So we're going to close this event now. Thank you. We appreciate for all the information that Raúl shared with us very kindly this morning on chemical risk. We have shared very important information on phytosanitary information, the database that are available for food safety that are included for all the Codex Alimentarius and risk assessment. We also review some of the assessment of the Codex database. We also learn in detail the 4 different phases, identify or risk, the characterization of risk, exposure assessment and risk assessment, and all the different recommendations and suggestions that Raul shared with us. He also was encouraging us to include very conservative data when it comes to estimate the maximum levels of exposure for our countries to protect our population. We also saw a lot of the information on the databases available, how to estimate concentration of chemicals. And he also encourages to share information that is available in our countries, to share it and upload it in the different database available. So all this information is important to estimate and to determine the maximum concentration that are acceptable for our region. And also the maximum levels acceptable for at local level. And so there's been a lot of information. I just allowed myself to give you just a quick summary. Thank you very much. It's been very interesting. We thank you for sharing these two sessions, especially this morning, to the OIRSA team, CECELAC team. Thank you very much for organizing these sessions. Also for the producers that have also brought a lot of information to strengthen the information available in our countries. Thank you very much, Raul, for your kind invitation to participate on World Food Safety Day, the event on June 5th. We can see that information is available. And so hopefully I will see you on June 5th, and let's start reflecting on that information. Are you really prepared for the unforeseen? Okay, so let's start reflecting ourselves. So let's prepare for the unexpected. Thank you very much. Warm greetings from Ecuador. Good morning. This information is going to be available in YouTube channel, so you can follow, or you can recommend others that weren't available to attend this morning. Thank you.